All right. So I'm going to talk about transforming design into code. So what I mean by that is, right now, as some of you may know, when you want to build user-facing applications, you will typically involve designers who will be in charge of creating all the screens, the pages, the layout, and then they will ship this to a front-end developer who will basically turn this into code, namely HTML, CSS for web apps, XML for Android, and so on. And then front-end developers will really shine when they will implement all of the functionality, the features, and the logic of the application. But as some of you may know, if you've been in this spot, building interfaces as a developer is quite a frustrating experience. It just kills the iteration cycle with the designers, is expensive, and if you ask any front-end developer to describe the experience of having to write HTML, CSS, they will typically describe something along these lines. And to give us a sense of scale, every single day, about 12,000 websites are being uploaded online and about 1,000 apps on the different marketplaces, which means a lot of frustration is going on as we speak. So the idea is, how to solve this problem? Well, we can just build a code generator, right? But the problem is, for which graphic software should you build a code generator for? Some designers are using Photoshop. Some others want to use Sketch. And there will probably be some new hot software in 2 months from now that we don't expect. So how can you build a code generator to match those different tools? And the other problem is, like, you are about to generate code. Which platform should you support? Which library should you include? And I like tabs. My colleagues prefer spaces. I want my code to look like good for me. And there is, how do we do that? How do we fit every single developer needs? And a solution, as I said, should work with any graphical editor, and it should produce code which is customized for everyone. So the idea is, can we use AI, which is kind of a buzzword this year, to automate part of this process? Can we put somehow an intelligent algorithm in between that would basically generate the code and allow developer to focus on what matters, which is implementing the logic, implementing the features. This is basically what we did. And just to put some term and jargon away, so AI is just a research field within which there is machine learning, which is another research field. But when everybody's talking about AI right now, they talk about deep learning. Deep learning is really the rock star of AI right now. And 99% of all the different research papers are using deep learning. And when I talk about AI, I'm talking about deep learning. So why do we need machine learning? Couldn't we just generate code the old good way using software engineering and engineering pipeline? Well, the thing is, without AI or using traditional AI, as I put it in quotes, you will have to pay experts to manually input rules and knowledge into the algorithm. So let's say you want to build an algorithm to detect cat pictures. Then you will hire a bunch of cat experts who will write down programming rules about what a cat is, which have limitations. Because if tomorrow you try to detect a cat which actually is pink, and none of your experts thought about encoding the concept of a pink cat, then it won't work. Using machine learning, you input a lot of training example, and instead of providing the algorithm with rules and knowledge, you will just tell the algorithm what the end result should look like. So if you want to detect cat pictures, you will just provide a lot of different cat pictures, tell the algorithm this is a cat, and eventually, if there is a pink cat showing up, your algorithm should be able to understand the concept of a cat and understand cat. So using machine learning and having this very nice generalization feature, can we actually build an AI to generate code for user interfaces? I mean, wouldn't it be cool if you could just upload a user interface image, which can be produced with any software, have some magic happening in the cloud, and download the code back? So what I'm going to describe now is pretty much a prototype to do just this. And I want to describe the way we did it in order to inspire you to maybe use machine learning in for your own problems, and also to let you realize that having a machine learning AI power solution is actually not that hard, which means we're going to use AI in our software engineering process in a very soon, small time scale. And if we look at the problem a little bit more carefully, what we're trying to do is to automatically identify graphical user interface component, like such as a button, and generate a code snippet that describes this user interface component. And you want to do this automatically, so the computer only sees pixel values from 0 to 255. Sounds like a pretty tough problem, right? But for every problem, we'll search for inspiration in research and what other people are doing. And deep learning have been extremely good recently of doing image captioning. And image captioning is the task of generating an English description given a photograph. This is basically what Facebook is using to describe pictures to blind people. So it works. It's not science fiction anymore. This has been like 2 years old research. And the assumption was, if you can use machine learning to generate an English description given a photograph, can you use the same approach to generate code given a graphical user interface mockup? In both cases, you're trying to generate text from an image. And the nice thing about deep learning is that it's statistical invariant. If you want to detect dog or cat or whatever, it doesn't matter which color is a dog. The algorithm should understand the concept of a dog. And the same with UI. A button can take different shapes, different colors, and so on. And once again, the concept of a dog doesn't matter where the word dog is in a sentence. And the same applies to code. Regardless of the place in your code where the button snippet should be, it's a button regardless of the position. And if you cut the problem into some small sub-pieces, you basically have a computer vision problem of understanding the scene. And deep learning gives us a really nice tool to do just that, which is convolutional neural network. I'm not going too much into details about what it is, but on a higher level, convolutional neural network allows you to extract features from images without having to tell the algorithm what to do. So if you want to build an image classifier that recognizes hot dog, you will just feed a bunch of hot dog pictures, and eventually the ConvNet will be able to understand what is a hot dog and what is not a hot dog. And the other problem, if you want to generate code, English, or any sequence of data, is to understand language. You need to be able to have an algorithm who understands the order of words, the order of the tokens. And deep learning research gave us a really nice tool to do just this, which is recurrent networks. And once again, without giving into too much details, recurrent nets have this recursion, which allows you to model sequence data. So this is extremely useful if you want to predict time series data, as people are using to predict the trading market or the stock. But you can also consider text as a sequence of characters and code as a sequence of token. So now that we are aware of those two different components, we can assemble them as Lego blocks and try to build a machine learning algorithm that generates code from user interfaces images. Now, what I/O should you have? We already know that we're going to use image as input. But do you want to output HTML? Do you want to output CSS? Do you want to output XML? We basically solve this problem by introducing our own language. And this very simple domain-specific language is designed to describe what a user interface is made of. Regardless of you working with mobile interfaces, desktop interfaces, web interfaces, all of these different interfaces contains buttons, labels, sliders, and so on. So we build this very simple programming language, and then we can train our AI to understand this language alone and compile from this language to HTML, to XML, and so on. So we have control over the target. So this is a model. I'm not going too much into details because time is running. And then when you generate the code, you basically generate one token at a time. You provide the graphical user interface, and you tell the algorithm, start generating tokens. And after some time, it generates one token at a time, and you get the full code generated for a given user interfaces. And the very nice thing about this very simple architecture is that you use image as input. So you could imagine inputting graphical user interfaces produced with any software. If some of you designers want to use Microsoft Paint because it's pretty cool, then you could, in theory, use the same approach using Microsoft Paint user interfaces. And on the developer side, because we have this domain-specific language, and then we can compile it to anything, if tomorrow Google or Facebook or whoever released a brand new front-end library, then we can support it. We just have to build a compiler, and we can use exactly the same AI to generate the code. Pretty cool. Does it work? Well, our proof of concept actually worked, to our greatest surprise. Here there is an example with a very simple iOS interface. And as you can see here, on the left, this is the expected result, and on the right, this is AI-generated user interfaces. There is some mistake, but it looks pretty close. Here on an Android user interface, you can see there is some mistakes. For whatever reason, the AI couldn't actually generate some of the buttons, just to show you where the pitfalls are at the moment. And here, interestingly, on a Bootstrap web interface, for whatever reason, the AI could model the layout of the screen, but for whatever reason, it didn't want to care about the color of the buttons. The stack is built on Python using the TensorFlow Keras deep learning libraries, and everything is trained on GPU on AVS. And for those of you who want to play with this proof of concept prototype, the code is available on GitHub, data sets as well, and there is also a demo video for you guys to check out the current version of the algorithm. Now, what now? So we've heard about deep learning a lot during the last year. It's being applied to a lot of different industries. But one of the main problems into using deep learning for real-world problem is the access to training data. And the reason I'm extremely excited about applying deep learning to front-end development is that there is an amazing amount of data. If you look at the web and you build a web crawler, you could imagine collecting screenshots of websites, the HTML code, and you basically end up with an infinite amount of training data. So it's really just a matter of time before front-end developer only have to focus on the logic, and the UI part should be completely automated. The also really nice thing is that you don't need to have manually labeled data. If you want to build a hot dog classifier AI, you will have to pay hundreds of hot dog experts to label the data as hot dog or not hot dog pictures. In our case, for any given user interface screenshot, the label is the code. So there is no problem generating training sets. So I want you to think a little bit about what the future workflow should look like. Because if you have an AI who can directly generate HTML, CSS, and then let developers focus on the logic, the amount of iteration cycle you can have with the designers is just boosted. You can imagine having way better product because you have more iteration in the same amount of time. And if you think a little bit further, if you have an AI who can understand the concept of graphical user interfaces just with image, you could basically let anyone use AI to build application. Anyone is able to take a piece of paper, sketch a user interface, then you throw this to the AI, and the AI can generate design files or code. So the idea is like we are really on the transition model right now where anyone could potentially become an application builder without any knowledge of code or design in the first place. So we really believe in a future where humans and robots collaborate to basically build better products, hopefully. And that's about it. I would be happy to answer your questions. Thank you.